Hi, I'm Alex, and welcome back to Alex the Pi Guy. In this video, we're going to do some practice problems for the last lesson, which is on the exponent rules, where we continued where we left off in the previous lesson. For this first question, we're just going to verify that fourth exponent rule. So in this first part, we have 3 squared, all of that to the power of 3. So first, we solve inside the bracket. That'll be 3 squared, which is 9 to the power of 3. And then 9 to the power of 3 is 729. Now we do the right side of the exponent rule, where we multiply our powers. So 2 times 3 is 6. And 3 to the exponent of 6 is, in fact, 729. Verified. Next, we have 2 to the 5th power, all of that squared. So first, we do 2 to the power of 5, which is 32 squared. Is 1024. Now we multiply our powers. So we have 2 to the 5 times 2 is 10. And 2 to the 10 is indeed 1024. Next up, we have 7 to the 4th, all to the negative 3. So we have a negative power in here. So first we do 7 to the 4th, which is 2401 to the power of negative 3. We can use the negative, like we learned in the lesson, to turn the base with the exponent into a denominator. And then we can do the power of 3, which is 138,412,817. Lovely. Now we can multiply our powers. So 4 times negative 3 is negative 12. Use the negative to make it a denominator. Sorry, on the answer, it is 1 over 138,412,872. And now we can evaluate our denominator. 7 to the 12 is, in fact, that really big number. And that's verified. In this second set of questions, we're going to simplify each expression using our exponent rules so that we have a single power. So in this first part, we have a squared times b squared, all of that to the exponent of negative 3. So first we can tackle inside the brackets here using the first exponent rule. This becomes ab squared to the exponent of negative 3. And now we can use our fourth exponent rule to change these two powers into multiplying together. We can multiply those powers. And if we wanted to have only positive exponents, we could change this negative by making the the base into a denominator. And then applying the power. Awesome. On to the second question. So we have x to the 6th divided by x to the 2 multiplied by x to the negative 2. So we'll start on the denominator here. We have the same base, so we use the second exponent rule to add the powers. Adding the negative is the same as subtracting. So we have 2 plus negative 2 is just 2 subtract 2. And then we're left with 0. But anything to the power of 0, as long as it's not 0, is 1. And we're left with x to the 6. On to the third problem. We have k squared divided by k cubed, all of that to the power of 4. Now we'll start inside the brackets here. So we have k squared divided by k cubed. Using our third exponent rule, we can change this into a subtraction of exponents. So this becomes k squared, subtract 3. So this becomes k to the power of 2, subtract 3. All of that to the power of 4. Subtraction gives us negative 1. Now we use the fourth exponent rule to multiply those two powers. So we have k to the negative 4. And again, if we wanted to only have positive exponents, we could take this negative to make this a denominator. So we have 1 over k to the 4. As a side note, another way to do this problem is to start with this power here, and when we multiply into the brackets here, we multiply to everything. So this becomes k to the 2 times 4 divided by k to the 3 times 4. It's k to the 8, k to the 12. We do our subtraction. K to the negative 4. Make that a denominator. It's k to the 4. And if you're clever, you can skip from this step to this step by knowing that the difference is 4, and this is the larger one, so the 4 is going to be on the denominator. So you can skip right to here and just write 1 over k to the 4. Anyways, that's it for these practice problems. Thank you for watching. I'm Alex the Pie Guy. In the comments, let me know what you liked, let me know what you didn't like. Drop a like if you liked this video, drop a subscribe if you want to see more, and I will see you in the next one.